So in this video, we're going to talk about how to graph inequalities in the number line. So we want to graph this particular one, x is greater than 3, so we're going to put 3 in the number line, and then also at least a reference point like 0. There's two numbers here, which we'll see in some of the compound ones, then you can just put the other number. Now, when you plot your 3, you want to know whether you're using 3 or not. So like, is 3 greater than 3? No, it's not. So 3 is not a number that is a solution to this inequality. Any number that's greater than 3, and the way of remembering whether this is a greater than symbol or a less than symbol is the less that makes the letter less, L. So this does not make an L, so it is not a less than. People always tell me it wants to eat the bigger number. Well, x can be any number it wants to. Sometimes it's greater than 3 and sometimes it's not. So what are numbers that are greater than 3? They're numbers like 5, 6, 7. So when we look at the number line, our solutions are numbers that are greater than 3, bigger than 3. So those are numbers on this side. So we're going to shade them off to the right. Now, if you're doing this in pencil, sometimes it's hard to show this line. So some people will put it off the graph to the right. Some people will just make it really dark. Some people will squiggle it. I'll do that often on the board. Mine will be squiggled to the right. Now, we have to make a difference between whether we can include 3 or not. So over here, like, negative 2 is less than or equal to negative 2 because it's equal to negative 2. So I want to count the negative 2. Here I don't want to because 3 is not greater than 3. So we would show that for the less than symbols, or the greater than symbols compared to the less than or equal to, and greater than or equal to, is we show open circles versus closed circles for these. So at negative 3 I have an open circle, and that goes to the right. Now we'll talk about interval notation here in a second, so let's do this problem as well. So negative 2 is less than 0, so it goes to the left. We have the equal to, so we're going to indicate that with a closed circle, and then we got to figure out which way we're shading. So this is a less than, so the smaller values are on the left, so we're going to shade to the left. Now another way of realizing which way to shade, which is a little bit of a trick, is that these make arrows. That arrow is pointing to the right, so you shade to the right. Now, the problem with that is this only works if x is on the left side. If you switch these and put 3 on the left and the x on the right, we still want 3 to be smaller than the x. 3 is on the small side. So when we do that, these two are the same expressions. However, that arrow appears to point to the left. So you can use this arrow only if x, the variable, is on the left side. So the arrow points left, you shade to the left. But it's safer to just use logic. We want the values that are smaller than negative 2 because x is less than negative 2. So those numbers are left of negative 2 on the number line. Alright, so interval notation. So that's just asking us what values have we shaded. Well, we shaded from 3 until, well, how far to the right? Forever to the right. So from 3 to infinity. And infinity is like a little sideways 8. And the question is, well, over here, we'll do that and then we'll talk about what we do at the endpoints. This goes from, well, you always read the left to right. So it starts from the left and it ends at negative 2. So from something to negative 2. Where does it start at? Well, everywhere to the left of negative 2, all the way from negative infinity to negative 2. So you have a negative infinity versus a positive infinity. Negative infinity on the left, positive infinity on the right. Now, the 2 and the 3 are not the same. This one doesn't count the 3, so that's why it's an open circle. And this one does count the 2, and that's why it's a closed circle. So we've got to do something down here to make the difference. So how we're going to do that is open circles are going to get parentheses, and closed circles are going to get brackets. So we're not counting 3, so parentheses, and we are counting negative 2, so bracket. Now the question is, do we count infinity? Does this number get all the way to infinity? Well, infinity is just the idea of the largest number ever, so you never quite get there, so that gets a parentheses. Infinities will always have parentheses. They will never get brackets because it implies that you get to them. But infinity is the idea of the largest number. It's not an actual number, so you can never actually get to infinity, so you never actually want to put a bracket on there. Alright, so what do we do when we have an inequality as kind of like an equation? So if you ever hear me say equation, solve this equation, that's actually wrong. I'm going to solve this inequality. So how do I do that? Well, we got a couple of things we could do. You could distribute this 5, 6 into it, but I really want to get it away from the x. So what I'm going to do is multiply by a negative 6 over 5 right off the bat. And it's going to make it go away from the left side and appear on the right. It's negative 6 over 5. Now, one of the key ideas, and that's the kind of thing that I jumped across up top there, is anytime you multiply or divide by a negative, you have to flip the inequality. So that goes from being a greater than to a less than symbol. Alright, so what do we end up getting? So this is a less than. Well, unfortunately, this doesn't break down nicely. You're just going to have to figure out what that is. So what is it? 6 times 1 is it's 6, but then 6 times 20 would be 120. So that'd be a negative times a negative. It's a positive 126 over 5. Okay, so that's what it is without the calculator. If you just type this in your calculator, you're going to get a positive, what should that be? 252. I think it should be 25.2. If you type this in the calculator. I don't care which way you do it, but that's what we should get. Now, the 25.2 is going to be a little bit easier to, just double checking that. Yeah, a little easier to do the next step, because on the left we still have this x minus 12 is less than that number. So we solve it just like we do any normal equation. We add the 12 over, we add the 12 over. So if you wanted to do this as fractions, you're going to have a little bit of trouble because you got to come to a common denominator. But if you use the decimal, then it's a whole lot easier. So x is going to be less than, well, 25.2 plus 12 would be 37.5. 37.2, sorry. Alright, so the goal is actually the interval notation, it's not the graph. But if we put them on the graph, we put 37.2 somewhere, and we put 0 to the left of that. It's an open circle because it's not equal to, and it's less than, so the smaller numbers are on the left, so we shade to the left. The interval notation would go from left forever, so negative infinity, all the way up to 37.2. 37.2 is an open circle, so open circles always get parentheses. Infinity doesn't quite reach it. Infinity also always gets a parentheses. Alright, so we're going to turn one of these real-world problems into an inequality and then try to solve it. So, at this particular one, Game-O-Rama Video Game Rental Company, you rent games for $3 each. There's one-time $4.50 sign-up fee, and you've got a gift card for this company. How many games can you rent? Okay, so we don't want to spend more than the gift card. So our cost for renting is going to be $3 for each game, and then we have just a $4.50 sign-up fee that's not for each game, just overall $4.50. So this is going to be the amount that we have to pay. We want to make sure that it's less than or equal to 50. Now I'm putting the equal to on there because if it was exactly 50, then fantastic, we don't care. Like, it would be all of our money, but we don't want to spend more than this. So this is why our amount that we're spending has to be less than or equal to 50. All right, now we solve it just like an equation. Subtract the 4.5 over, and you get 3x is less than or equal to 45.5. And then from here, we just have to divide by 3. Now, we only switch the inequality when we divide by a negative, or multiply by a negative, but we're dividing by a positive number, and even if this was a negative 45, we're dividing by 3. So now all we do is take 45.5, we divide it by 3, so we get 45.5 divided by 3, and we get 15.16666. Okay, 15 and 1/6, I believe, but you can't really have 0.16 of a game. So let's write that down really quick and just see what we get. So x is less than or equal to 15. I believe it was 1666. Now, we can't rent 15.166 games, right? So how many can we rent? Well, and remember, x was the number of games. I mean, it has to be less than or equal to it. So I know that some people want to round down just because 0.1 is smaller than 0.5, but we can't rent anymore. If we rent over that, if we rent 16 games, then we would be spending more than our 50 amount. So we have to spend less. So we can rent 15 games. And then we have some change left over.